changing quantity, average speed, functions, and limits. These are the parts or features in this subject. Hello classmates. From my classroom, I'm teacher Kyle, and I'll be your math teacher for this coming school year. I'm going to answer you a simple question at the end of the video. So for now, we are going to have math and welcome to a new series of a topic about basic calculus. So anyways, let's sit back, relax, and let's listen to our lesson for today. Our topic for this video is about basic calculus. According to the internet or textbook, calculus is defined as the changing quantity and is a branch of mathematics that involves the study of rates of change. Before calculus was invented, all math was static. It could only help calculate objects that were perfectly still. But the universe is constantly moving and changing. No objects, from the stars in space to subatomic particles or cells in the body, are always at the rest. Indeed, just about everything in the universe is constantly moving. Calculus helps to determine how particles, stars, and matter actually move and change in real time. Phrases for this topic are renew, replace, amount, number, much, many. So students, changing quantity refers to a change in the specific quantity of a distance, amount, or replacement, as 4 questions in a topic. 1. Moving a car, how fast? 2. Running a person, how large is the blood pressure? 3. Things/objects, how things or objects going down into the ground? 4. Prices, high or low, how fast is the highest price of face mask? So basically, the examples are the situation that will give us an idea about the changing quantity. In science, we also called this phrase as the speed of a moving body. When you say moving body, it refers to any moving object. The formula for speed of a moving body goes like this: speed is equal to distance over time. How fast is the child? By using the formula, we'll just plug in the values. This will be, speed is equal to 100 over 10, speed is equal to 10 meters per second. This, the speed of a child running, is the result of a value. Let's move on to another question. Can we give the exact speed in a particular point in time? For example, after 2 seconds, how fast is the car runs? Or 5 seconds, or 5.7 seconds? The exact formula is no, because there is no solution in an exact speed. We've chosen the formula as the estimates. Estimates known as the average speed. So, meaning, it doesn't matter if it's fast or moving when the moving car from point A to point B given by the average speed of a moving object. But it will not give us an exact value at a given point in time. Let's put this in a graph. If we want to make this an average speed, this is the style of the graph like this. It's just a straight line, therefore it's an average speed. So the question is, does the car has an actual movement if there's an engine of itself? So you know, it's not. If the movement goes like this from 0 as fast as much, you've been injured, or you've hit by itself. The actual movement of this moving car or the actual speed of this moving car. This is the style of an actual movement of a starting vehicle that restarts to 0. When the car is crossing the road with humps, after it stops, the car will become faster as such. An actual movement of a moving object which is not the same at the speed of the moving object that gives to them is an average speed. But let's compare the two of them. I want you to know the moving object or this moving car after 30 seconds. How fast it is. If we'll draw a vertical line here, it will intersect at 2 distinct points. So we say, if we can see the average speed, for example, it will just give us a 20, but the actual movement of the car starting is 50. So by the way, mathematics is an exact science and we want an exact value at a given period of time. Which speed formula or the average speed is not enough, so you can answer this question. Another example, after 60 seconds, I want you to train your problem and I would like for you to know your answer. As you know, that it is no problem, because it'll just intersect at one point, but if we'll move from the left or we'll go on after 70 or 80 seconds, they're both the same to get the time definitely. By this figure, we'll not arrive at the same answer, and here's what we enter, that we called calculus. Calculus, we don't just rely on average speed, we are interested in finding out what is the amount changed at a given period of time. This is what we called instantaneous speed. Instantaneous speed is the speed of an object at any particular moment in time. Examples: weather forecasts, disaster risk reductions, and planets in outer space, rate of growth, how quickly multiply, how long is life, how easy is it to have spending a lot of time in outer space. So basically, calculus will give us an exact answer to these questions. But you might be wondering, if there's a computation there, not to say calculus, there are so many computations, these are so many things to solve. The mathematicians are making mathematical models that you'll describe in a moving object. For example, the growth of the bacteria was made by the mathematical models, and this is what we called functions. It looks familiar. Look at these formulas. These functions are familiar to us, because we took that for granted when we were junior high school, and we were its general mathematics. We've been encountered those of the functions. And these functions, it will all make sense if let's get into the subject of basic calculus because we can use them. These are all concepts that were ignored when we were in grade 10, when we entered basic calculus, and what will give us a bridge from our general mathematics class, they will go to basic calculus is the concept of limits, in which will be our topic for our next video. So everyone, if we understood our lesson, let's answer this question. What is the meaning of calculus, and what are the uses? If you know it, leave your answers in the comments section. I wish class is near, so you will know about the lesson or topic. And I think that's all for this video. Goodbye. And see you soon.